In the last lecture module, we introduced the notion of arguments. We talked about how arguments were structured collections of states. We talked about some of the useful functions that arguments serve. Now we want to turn our attention to the basic constitutive elements of arguments. Specifically, we want to start looking at statements. So we're going to start by just defining what it is to be a statement. Since the Hurley text talks about propositions as well, we'll talk about propositions in relationship to statements. Then we'll talk about the truth value that a statement has. And finally, the probability associated with any given state. So let's begin. A statement is an expression in a language that is capable of being true or false. So for example, this house is blue. Today is Tuesday. I live in Long Beach. All of these statements are true or false. They're accurate depictions of the world, or they fail to be accurate depictions of the world. Of course, not all well-formed expressions in a language are statements. So for example, how do you get to the blue house? It's not a statement. You wouldn't respond to that by saying true or, oh, that's false. Likewise, look out! Not a statement. Wouldn't say, oh yeah, look out! Absolutely true. There are elements of our language that are capable of being true or false, that are accurate or inaccurate depictions of the nature of the world. Other elements of our language, also well-formed grammatical expressions, are not statements. They're just not the sort of thing that get truth values. So statements are expressions of a language that can take a truth value, and a truth value is just simply the value of a given statement. Is it true or is it false? So, for example, when Bill Clinton infamously said that he did not have sex with Monica Lewinsky, that was a false statement. Its truth value was false. Just as when his successor claimed that Iraq had weapons of mass destruction immediately prior to the recent U.S. invasion, that was false. So, truth values are just the actual value. Now, oftentimes we don't know what that is, as we'll see, but the actual value of that statement, whether it describes the world accurately or whether it fails to do so, that is the truth value. Hurley also talks about propositions. And for our purposes, in the context of this text, proposition can be used interchangeably for statement. Technically, a proposition just is the name that we use to refer to the abstract content of a given statement, what it expresses, regardless of how it expresses it. So, le crayon est bleu and the crayon is blue express the same proposition in two different languages. So again, a truth value is just a binary value, one or the other, true or false, that indicates whether or not a statement accurately models some part of the world. So if I say I rolled a 3, but you look at the face of the die and it's a 6, the value is false. If I say I rolled a 6 and you look at the face of the die and the face of the die is 6, then I said something that is true. Now, because statements have truth values, they also always have probabilities. And specifically, in a complex and variable world, we may not know the truth value of a given statement. We might have evidence regarding the statement's truth value. We might have reasons to believe it's true or reasons to believe it's false. Those reasons may not be definitive. Probabilities, therefore, are just ratios that indicate the likelihood of a statement being true. Thus, probabilities allow us to understand and to reason about statements based upon their likely truth values, even when their actual truth value is unknown to us. So this is Girolamo Cardano. He was an Italian mathematician who helped create the classical theory of probability. Probability, for our purposes now, is just going to be equivalent to the likelihood of something going to happen. Specifically, the probability of a statement is just going to be the favorable cases, the way the world turns out where the statement is true, divided by the total number of possible cases, all the different ways the world could turn out. So the probability of some statement S will just be equal to the ways the world could turn out where S is true, divided by all the different possible ways that the world could turn out. because the number of favorable cases, the ones that make the statement true, can never exceed the total number of cases, all the possible ways the world could turn out. The values for probability range between 0 and 1. A value of 1 means the sentence is true with certainty. Favorable, the ones that make it true, are the exact same number as the total possibilities, all the different ways the world could turn out. And so f divided by n would equal 1. A value of 0 means that it's impossible for a sentence to be true. That is, the sentence is false with certainty. Now, all the values intermediate between 0 and 1 represent the likelihood of the statement being true, expressed as the value of f, favorable outcomes, divided by n, total number of possible outcomes. So let's look at a couple of illustrations. Suppose I roll a die, and I want to know what the probability of my rolling a 5 is. There are 6 faces on that die. Only one of them has 5 dots. Therefore, there's 1 favorable and 6 possible, 1 over 6. If I want to know the probability of my rolling either a 1 or a 3, then there's still 6 possible outcomes when I roll that die. But now there are 2 possible outcomes that would make that statement true. I roll a 1 or I roll a 3. Hence, the probability of rolling a 1 or a 3 is 2 out of 6, or 1/3. In the next lecture module, we'll turn our attention from these individual component elements, statements, to look at the structure and function of that collection of statements that is the argument itself.